Okay, welcome back to integration in Google Docs. So today we have a trigonometric integral. Firstly, if you want, you can pause the video and try it yourself. But if you don't want to try it yourself, then just continue watching and let's begin the solution. So firstly, we see this cot and it kind of makes sense to write it as just cos over sine because we don't really want to deal with the cotangent. So this would just be cos to the 4 over sine to the 4. Okay, pretty simple to start off with. And then it also makes sense to multiply by sine to the 4. Now it's a bit more confusing what we should do. So you might think about doing this plus minus thing, and that would get you to cancel something with the denominator. But then if you do that, we're only left with 1 minus cos to the 4 over sine to the 4 plus cos to the 4. And this other integral isn't really that useful. It's not that much different from the original one. So we're going to do a slightly different manipulation. So we just multiplied by half and times by 2. So why are we doing that? Well, now we can write this 2 sine to the 4 as sine to the 4 plus sine to the 4. And now we're going to do the plus minus. So we add a cos to the 4 and subtract a cos to the 4. So we haven't changed the integral, but we've written it in a different form. And this form is quite useful because we've introduced this sine to the 4 minus cos to the 4. And that's going to give us a difference of squares. But also we can cancel with the denominator. So let's rewrite this. So when we split up the fraction, we get a 1 here. And we're adding this thing. Okay, cool. So we can simplify this first part. The integral of 1 is just x. And the rest is just this. Now, we're going to use the difference of 2 squares on the numerator. That seems pretty nice. And you'll see why it's even nicer than you might expect. So obviously this would just give sine squared plus cos squared times sine squared minus cos squared. And yeah, so you can see it now. Sine squared plus cos squared is just 1. So that really simplifies things. Also, sine squared minus cos squared reminds me of the double angle for cosine. And cos squared minus sine squared is just cos 2x. So might as well replace that up there. And now we want to write the denominator in terms of sine 2x, because that way we can do a u substitution later. And there's actually a pretty cool way to do this. So now we'll just replace this sine squared with 1 minus cos squared. And we'll just replace the cos squared with 1 minus sine squared. Yeah, okay. Now all we have to do is just expand this denominator out. Yeah, so now you can see another time we use sine squared plus cos squared is just 1. So we can just replace that sine squared plus cos squared with 1, and we're left with, let's see, 1 minus 2 sine squared cos squared. So that's already really good. We've simplified it, we've removed the fourth powers, and now this sine squared cos squared, well, that's just sine x cos x all squared. And then sine x cos x is obviously half sine 2x. So that's how we introduce the sine 2x. And now we're just going to do some simplification. So this half becomes 1 on 4 when you square it. And then we have a half here. And, well, we can use this to just simplify this. So that would be a 2 minus sine 2x all squared. Okay. Okay, so now we can do a u substitution letting u equals sine 2x, but you don't really have to do it. You can just see that the derivative of sine 2x is 2 cos 2x. So that's how we'd compensate for it. And then, well, okay, if you do the u sub, it's really not that much different. It's just this numerator would become 1, and then we'd have du. And this thing would just become u squared. Okay, yeah. And that would just be 1 on 2 square root of 2 here times the natural logarithm of square root 2 plus this thing here, sine 2x, over square root 2 minus sine 2x. Yeah, so all I did here is I used this formula. Let me write it down. So the integral of 1 on a squared minus x squared is just 1 on 2 a ln absolute of a plus x on a minus x. Yeah, we solve the integral. And yeah, so the integral of 1 on 1 plus cot to the 4 is this thing here.